This meeting is being recorded.
All right. So from yesterday class, we discussed about
Routing
how do we do a lab on the HSRP. We have seen the condition like if a link go down, how will the HSRP failover, and if we adjust the priority, how the failover will be happening on the HSRP in the lab. After that, we talked about inter-VLAN communication. So to make two subnetworks or two VLANs communicate between them, we have taken a layer 3 device like a router, and we did a lab on the packet tracer with the router on a stick concept where we created sub interfaces and we let router do the connectivity between the VLANs. You guys have any questions on the routing part? I mean to say like inter-VLAN routing from yesterday class. Okay, all right. Yesterday, Mahita asked a question about VTP versus DTP. I was confused. I was thinking that she was asking about modes of VTP, but she brought in a different question. That is, what is the difference between the VTP and the dynamic trunking protocol? So dynamic trunking protocol is what we discussed in the past, like .1q trunking, where we tag the interface, where we tag the VLANs, right? Where we use a tag for the VLAN and we allow multiple VLANs on a single link. That is called dynamic trunking protocol. And VTP is like a different concept. So in VTP, let me start sharing my whiteboard. So let's say you have a switch and you have another switch and you have another switch, another switch. Let's say switch 1, switch 2, switch 2, switch 3, and switch 4. So let's say you have created VLAN 10, VLAN 20, VLAN 30, VLAN 40 on this switch, and you wanted to replicate the same VLANs on all these switches. Okay. Instead of you manually logging into each switch and creating VLAN 10, 20, 30, 40 on each switch, you can put this as the master, which is called the server mode. And then you can put these as the slaves or the client mode. And you can use a protocol called VTP, where you can push this VLAN database to all the switches without manually configuring it. That is VTP. But this has nothing to do with the trunking protocol that we discussed, where we allow multiple VLANs on a single link. VTP is to sync the database between the switches, where you create the VLANs on one device and you will sync the database to other devices by putting them in the client mode. And the device where you create the VLANs to forward the database is called server mode. That is VTP. Is that clear now?
Oh, yes, sir.
Sir, can you say it again, please? Sorry.
What part?
So, like VTP.
I want you to go back and listen to the recording if you're not paying the attention. Okay. Let's start talking about the routing. Routing fundamentals. So routing fundamentals will help us to communicate networks between them with the help of a router. Like we discussed yesterday, we took two VLANs. This is VLAN 10 and this is VLAN 20. If the VLAN 10 wants to communicate with VLAN 20, this cannot be achieved with the help of a switch. A switch cannot able to make VLAN 10 communicate with VLAN 20. But switch can only do devices in VLAN 10 communicate them with the help of a switch. So when you have two devices, if they are part of one VLAN, a switch can be helping to make them communicate. But if you have a VLAN 10 and VLAN 20, and if you want to make them communicate, you need to have a router. So a router is a layer 3 device. If VLANs are the layer 2, if layer 2 wants to talk to another layer 2, it needs to have a layer 3 device between them. So my point is, if you have 3 or 4 PCs, they are part of one VLAN. If you have another 3 or 4 PCs, they are part of another VLAN. We separated them for a reason, right? So in the layer 2 domain, if you have multiple PCs, we are separating them for a reason. And if we want to make them communicate, that will be possible only with the help of the router. So you cannot make two devices communicate. Sorry, you cannot make two VLANs communicate with the help of a switch. A router will be able to make them communicate. So now, how does this router will do that? How does this router will be able to make two VLANs communicate? Let's see what is the functionality behind that. Okay, so now let's say PC1 wants to talk to PC4. Okay, so now the IP address of the PC1 is 10.0.0.10. Okay, the IP address of PC4 is, let's say, 20.0.0.40. Okay. So now, as we know, initially the PC1 will check its ARP table. When we start trying to send the ping request, it will check its ARP table. So first step, the PC1 will check its ARP table. Obviously, it will not know the destination MAC address. The ARP table cannot bind the IP address of PC4 to the MAC address of PC4 because it does not know it. So then it has no choice other than broadcasting it. So it will send the unknown destination packet to the switch, unknown destination frame. We can call it as a frame because it does not know what is the MAC address of PC4. So the switch will get it. Now switch will try to broadcast to all the ports where the VLAN 10 is configured, right? So that frame will goes to PC2, PC3, and also it will try to send the above link because we configure this as a trunk port and we allow VLAN 10 here. So now that frame goes all the way to the router. Now the router has to check its router ARP table. Okay, the router will see what is the MAC address of 20.0.0.40. Obviously, there is no resolution. Even router does not know what is that ARP entry. Next, it will see, okay, what is the part of this network? Okay, it's learning from this interface network IP. So this should be part of something like 20.0.0.1. Because remember, we will define this interface as the gateway IP. So we know that, okay, it's part of this gateway and that gateway is part of VLAN 20. So now router thinks that, okay, I'm learning 20.0.0.1 via VLAN 20. I'm going to broadcast that frame to the VLAN 20 because it is trying to look something in 20.0.0.40, which is in the same subnet as 20.0.0.1. So now router will send that frame to that switch. Now switch will, with the VLAN tag of 20. So now switch will get the VLAN tag 20. It will broadcast to PC4, PC5, and PC6. PC4 will respond back to the switch saying that it is the 20.0.0.40 and it will send its MAC address. Switch will store that in the MAC address table of the switch, will send the data to the router. Now router in the ARP table, it will bind the PC4 MAC address to the IP address in the router ARP table. And that will send the MAC address to the switch. Switch will know that MAC address from the uplink router and it will send back to the PC1. So now PC1 knows that from the gateway router. So from next time it will automatically point to the gateway and the gateway will point to this ARP table of the PC4. So here router was able to get this subnet 20.0.0 network and this 10. network via gateway IPs. So a router, because the gateways are configured on itself, it knows PC1 network is 10. network and PC4 network is 20. network because we configured both the gateways on the router itself. So with the help of the routing table, the router will be able to identify whether the PC1 is part of the 10 network or PC4 is part of the 20 network. If you don't configure the gateway on the router, it does not know what part the destination is. If you did not configure 20.0.0.1, obviously router does not know the destination is part of this network. So you have to have a gateway on the router to route the packet. If it does not have the gateway, then we need to have some sort of routing protocol to route the packet. We are not there yet. We will discuss more when we go that route, how the router will be able to make communication between two subnetworks when the destination is not directly connected. But here in this case, the router destination network is connected to this interface and the source network is connected to this interface, and both of them gateways are configured on the router. That's how the router can be able to make two networks communicate with the help of the gateways. Any questions on this topic?
Sir, before it goes to the router, it will check in the switch itself, right? Just a small question.
Yes,
So
it will check in the switch. It will try to see whether that MAC address, it can find the MAC address because initially it's a broadcast packet, right? So when the PC1 is sending, PC1 will send what? Broadcast packet. Broadcast packet means all Fs.
Yeah.
So switch will say that, okay, I don't know what is the destination exactly. So I'm going to broadcast to the router and then other PCs.
Okay. Thank you, sir.
Sir, at a time it sends to the other systems and router, or after getting to the other systems, after if it is not getting reply to the switch, then after it will send to router.
It will broadcast to all the ports where the VLAN is configured.
Okay, at a
So
time.
it doesn't know whether it's a PC or router. It doesn't know what it is. The other end, it doesn't know. It will broadcast to all the ports.
Okay, fine, sir.
Any other questions, guys?
No, sir.
Okay. So now we know that router will be able to find the destination with the help of the routing table. Now there are conditions to select the best path on the router when we have multiple routes. What is the best route to reach the destination? So that is what the routing fundamentals are. So in the routing table, let me clear this diagram. Or I can do something like this. Okay, so now when the PC, we have a PC here, it's trying to reach this destination. Let's say this is URL, any URL, let's say CCNA-journals.com, okay, my web page. Okay, it's trying to go that. So now this PC, when it comes to the router, it has three paths: path 1, path 2, and path 3. So the router should choose best path to reach that URL. Okay, to choose that best path, it has the conditions, right? So just think like you are on an you're trying to go to a specific address. Okay, you for example, if you're writing a mail, like a postal mail, and you have 4 addresses to point to. Okay, so let's say you have a mail that you want to drop, and you have a postal office, FedEx office, postal office, whatever, right? So you have 4 addresses that you wanted to point to. Okay, the postal office. So one is, the first address is state address. Okay, so let's say it's Texas. The second address says Richardson, Texas. The third address says McKinney Drive, Richardson, Texas. The fourth address says 140 McKinney Drive, Richardson, Texas. So there are 4 paths to the destination. So one path says the address is going to Texas. The second path says it's going to this city. The third path says it's going to this street. Fourth path says this is the home address, house number, street name, city, and state. Now you tell me which one is the most valid address.
Fourth one.
Fourth one.
Yeah, so fourth one is like more legitimate because it is having a more particular, more specific address. When you wanted to send a mail, that should have the longest match where your address should be going to, or the exact match. Similarly, router also should have longest prefix match. So this concept is called longest prefix match in routing. So now, how does this will be mapping to router means? Let's say on the router, you have four paths in the router again. So in that path, okay, so this is a big group. Okay, so let's say the group is /24, and inside that group there is a /26. Inside that group there is a /28, and inside that you have a /32. So here the /32 is nothing but the individual PC IP. So /32 individual PC IP. A /28 will be group of PCs that are part of one VLAN which got 14 PCs. A /26 will be a group of VLANs where that four VLANs /24 group of subnetworks or subnetworks. So that is how we are separating, right? So if the router wants to go to the PC IP, it got one routing says it has the direct address to the PC, which is the more specific address, which is the /32. The other router says I have a specific route of a VLAN. That VLAN will have 14 PCs. So that will be the next best one. The other one says I have a route to the group of VLANs where mine is a subnetwork route. I can show you /26. The other one says I have a network address which has 4 subnetworks. Mine is /24. So in this case, which one is the most preferred route?
/24 because it has like a clear information, I think so.
32.
/32.
/32, because the /32 is the longest match for the PC. If you take the PC IP, this has the most valid IP, and group of PCs will be part of /28. because you have like 14 PCs, it's not pointing to each PC, it's pointing to all the group addresses. And those kind of groups are 4. If you map them together into 4, that will give you a /26 address. That's a subnetwork. And those kind of /426 will be mounted to /24. It's a big network. So here, /32 is the longest prefix match. And how do you calculate this? This thing is, there is a method to calculate. Okay. So let me represent. So /32. Okay.
So here, instead of biggest network, we'll choose the longest one, right, sir?
Yes.
Okay.
Instead of biggest network, we have the longest prefix match. Correct.
Yeah, okay, sir.
Okay. So now, so /32 equal to, we have to define. So these are nothing but the number of ones. Okay. So I'm writing the /32 as, I'm dividing 32 into 4 groups. The first group will have 1, 2, 3, 4, 5, 6, 7, 8 ones, dot, again 8 ones, dot, again 8 ones, dot, 8 ones. 8 into 4 equal to 32. So this /32 is represented into 4 octets. Each octet will have 8 ones. So that is making it as 32. Okay. So now let's write how does these ones will be represented. Okay. So if I write 1, 1, 1, 1, 1, 1, so 8 ones, I am representing each one as like this. So the first one is 2 power 0. Okay. The second one is I should put some spaces. Okay. So the first one represents 2 power 0. Two power 0. The second one represents 2 power 1. The third one represents 2 power 2. 2 power 2. The fourth one represents 2 power 3. This one represents 2 power 4. This one represents 2 power 5. This one represents 2 power 6. This one represents 2 power 7. Okay. So every one, so I'm gonna put some spaces. This one is 2 power 6. This one is 2 power 5. This one is 2 power 4. This one is 2 power 3. This one is 2 power 2. This one is 2 power 1. This one is 2 power 0. So now let's put what is this include. Okay. So 2 power 7, 128. 2 power 6, 64. 2 power 5, 32. 2 power 4, 16. 2 power 8, 2 power 3, 8. 2 power 2, 4. 2 power 1, 2. 2 power 0, 1. If you count all of these numbers, 128 plus 64 is equal to 196, plus 32 is equal to 224, plus 16 is equal to 240, plus 8 is equal to 248, plus 4 is equal to 252, plus 2 is equal to 254, plus 1 is equal to 255.
255.
So 255. So a /32 can be written as 255.255.255.255. So this is the longest prefix match. This is the exact IP address that can be written for an IP. So for example, if your IP address of a PC is 10.0.0.0.10/32, that means that it is an exact match for the PC. Okay, so now what is /24? Or let's say what is /28? That will be all ones dot all ones dot all ones. That makes 24 ones. Remaining, I have 4 ones. 1, 2, 3, 4. So this is 8 plus 8, 16 plus 8, 24 plus 4, 28, and remaining all zeros. Okay. So if we change that, 255.255.255. How much? If you add first two numbers, that will be 192. The third number is 224. The fourth number is 240.240. So this is the representation. So a /28 can be called as 255.255.240. Are you guys able to follow this?
Yes, sir.
Yes, sir.
So to calculate the number of hosts, okay, if you consider /32 is equal to single host, it is a single exact match of the IP. Now, how many hosts will be there in /30? So there is a formula for this one to calculate. So to calculate the number of hosts in a /30 is equal to 2 to the power 32 minus n minus 2. That makes 2 to the power 32. N is equal to, for which we are calculating, 30 minus 2. That makes 2 to the power 2 minus 2. The answer is 2. So for /30, you will have 2 hosts. Similarly, so that means that in the /30, you can have 2 PCs. Similarly, for /28, 2 to the power 32 minus 28 minus 2. 2 to the power 4 minus 2. 14. Now tell me how many IPs will be there in /24? 2 to the power 32 minus 24 minus 2 to the power 8 minus 240. So when the number of PCs increase, when the number of hosts increase, that's a bigger group. So this group is having 254 PCs. This group has 14 PCs. This group has 2 PCs. This group has 1 PC or 1 host. So which one is the best route, guys, out of these 3?
32.
32 is the best route because it is a single host. This has the more matching. This has 14. This is the next best. This is the last best because it has a group of 254. So the smaller the group, the better the preference. So this group has only 1. This group has 2. This group has 14. This group has 254. So /34 is the most preferred one. Any questions on the calculation, guys?
No.
Okay. So
How
now,
did you get how did you get 2 to the power of 8 minus 2 is 254?
2 to the power 8 is equal to 256 minus 2 is equal to 254.
Okay, calculation. Okay.
Well, you know how we do powers, right? 2 to the power equal to 2. 2 to power 2 is equal to 4, right?
Yeah.
Okay, just making sure. Okay. Any questions, guys?
Sir, if we write like 10.0.0.
same instead of 32, if we write 28, what will be the possible IPs? What we need to understand by that?
Not following the question.
If we write like 10.0.0.10 slash instead of 32, if we write 28, means what we need to understand that what are the IPs, like what are the hosts could be.
You're asking about how do we calculate the host in that subnet?
Yes. I mean, that are the IPs, right? If you are saying if slash 30 means 2 host, right? So
Well,
if I give an
let's
IP
take an
and
example, right? Okay, so 10.0.0.0/24 if you have written like this, okay?
means how, yeah.
Okay.
What
So
are the
now,
IPs?
yeah, I understand. So now,
Okay. Thank you.
if it says 24, how many hosts will be there? 254. 254, right? So now that means it starts from 10.0.0.0, which is the network IP. It starts from 10.0.0.1. It goes up to 254. So 10.0.0.254. So this is your host entries. Because you know with this formula, it has 254 IPs, right? So it starts from 10.0.0.1 to 10.0.0.254. So in that subnet, you can go up to 254 hosts.
Okay, sir. Thank you, sir. Got it.
Any other questions, guys? Okay, so now we know what is the longest prefix match is. Now let's see if both of the routes are having the same prefix. Let's say so in this router, there are 2 hops. This one says a /24 route, and this one says a /24 route. So both of them are having the same prefix match, meaning like the same subnet it's learning from. So it has 2 paths which are equally same in terms of the addresses. So then which one it has to take, whether it has to take the path 1 or path 2, right? So there is a condition. Right, so we have path 1 and path 2. Which one it has to provide? Which one it has to take? Whether it has to go via this way or this way. So then the next tiebreaker is the administrative distance. Administrative. To understand this concept, I want you to think modes of transportation when you are doing a path to path, right? I want you to think like putting a Google map in your car, and then you have 2 paths. Which is the best path to take will be calculated by a lot of things. It can be calculated by the shortest time. The first thing, whichever is the shortest time, it goes that, and then it will calculate if the times are equal. It will see if there is any traffic. To avoid the traffic, it will try to take one path over the other to reduce the amount of traffic, because it may get busier, right? So it will avoid that paths. And then there are conditions that you can put like tolls. You can put like toll information like avoiding tolls. Next condition you can put is like avoiding highways. Those are the different conditions you can put in your Google Maps to choose one path over the other. Similarly, in routing, you have different routing protocols like static routing, let's say connected routes, static routes, EBGP routes, IBGP routes,
OSPF.
OSPF routes, EIGRP routes, ISIS routes, external EIGRP routes, external OSPF routes, redistributed routes, RIP routes, like these kind of different routes are there, right? So every route will have a admin distance value. Okay, so these routes are industry standard values that are try to maintain equally on all the vendors. So when this happens, whichever protocol, whichever routes has the smallest AD value, that path will be preferred in routing. So when the longest prefix match is same on both sides, when the longest prefix match is same on both sides, then you have to choose the best path with the help of the AD value. So the connected route's AD value is 0. The static route's AD value is 1. EBGP AD value is 20. IBGP AD value is 200. OSPF value is 110. EIGRP is 90. Okay, and then ISIS value is 115. I mean, ISIS value is 160, not 115, sorry. Depends on levels, right? So 160. Again, so Juniper does it 160, Cisco does it 115. So because we are talking about Cisco, let's put it 115. And the RIP value is 120. All right. So whichever has the lowest AD value, that path will be preferred. Now, in this case, in our example, okay, so in our example, we have two paths. The path 1 is learning via EIGRP. The EIGRP value is 90. And the path 2 is learning via OSPF, which is 110. So now, which path will be chosen? 90 or 110?
90.
Yeah, because EIGRP value is 90. The lowest AD value is preferred. So the EIGRP value is preferred when both the prefixes are same. When both the paths have the same prefixes, they will use the smaller AD value. Okay. So the next condition. Now, what if both of them are EIGRP? So even this one is EIGRP, even this one is EIGRP. Okay. So now, what happens if both of them are learning from the same protocol? Then comes the value of metric. Okay. So if both the paths are learning from the same protocol, next comes the value of metric. Okay. So now, to understand the metric, I want you to think about the cost. So now you are trying to fly to a destination in a flight. You have two airlines. Both of them are the same flights, same airlines, same distance. Everything is matching. So now what you will do is you will choose whichever is the lowest cost, the budget. You are using one with the lower cost. So let's say you are trying to go from A to B. You have two paths, path 1, path 2. Both of the paths have same time. Let's say 24 hours. This one is also 24 hours. Let's say you want to fly over Emirates. This one is Emirates. This one is also Emirates. It has no layover. This also has no layover. So every condition is matching. But this cost is $1,000. This one is 2,000. there is no brainer that you will pick this one, because everyone wants to have economy with all the comforts. So similarly, in your router, if you have two paths and both of them are /24s or any prefix /24, and if both of them are learning from same routing protocol like EIGRP and EIGRP, then you will choose metric. Whichever has the lower metric value, that path will be preferred. So metric is nothing but you can say in EIGRP, a value that is calculated by the relation of bandwidth and delay. We will discuss that when we talk more about EIGRP. In OSPF, we will use it with the help of the bandwidth. So whichever has the lowest metric, that path will be preferred. So here, let's say the metric of EIGRP path is 100 and the metric of the EIGRP path is 10. So obviously, it will choose the lowest metric. So the first condition is the longest prefix match. Second condition is AD. Third condition is the metric. So what happens? Both of them are same metric. So this one is metric same. This one is metric same. Both of them are metric 10. Now what? So if the router,
It will share one packet
Load
with one
balancing.
yeah, it does load balancing. It's called ECMP. If every parameter is matching, your packet can go either of the way. It can choose path 1 or path 2. It can load balance between both of them. There is no condition. So if you have a router and you have path 1 and path 2, if conditions 1, condition 2, condition 3, if all of them are meeting, if all of those conditions are getting met, then the path can either be 1 or path 2. Because everything is matching, then it's load sharing between both the paths. So that is the routing conditions to elect the best path. So the first condition is longest prefix match. The second condition is AD. Third condition is metric. Fourth condition is ECMP. There is no condition, it's sharing the load between both of them. Okay. So any questions? Okay. All right. So now tell me, guys, how many hosts are there in /27 and /23? Which one is smaller and which one is preferred path? Put your answers in the chat. My first question is, how many hosts are there in /23 and /27? Yeah, /27 is preferred. That is correct. But
30, but
to prove that
27 is
30 in /27, someone said 30. Okay. All right. Someone is saying
30.
30. Okay. What about /23? Someone says 32. 32 is wrong because you have to do 2 to the power n minus 27 minus 2. That will give you 32 minus 2, 30 hosts. $510 in 23. So that is 2 to the power
510.
32 minus 23 minus 2. So that will tell 2 to the power 9.
510.
2 to the power, what is that? 2 power 9, right? Minus 2. 512 minus 2. 510. Okay. So 510 in 510 hosts in the /23 network. And which one is smaller? /27 is smaller, and that is the preferred path. Okay. So that is how you will calculate. Now also tell me, what is the representation of /26 in subnet format? Or because we are doing already /23, let's do /23 in subnet format. So write down how does the /23 will be looking in the subnet format. Someone said 2.192, yeah, that is right, but that is /26. So now, yeah, that is, I'm asking now for /23. Write down the subnet format for /23. First, write the binary format. And then next, write the subnet format. $255, $255, 253.0. No, that is wrong. Okay. Yeah, binary. Someone wrote this one. Let's see. 8 plus 8, 16 plus 7, 23. Yep. So this one is right. And then I got the answers 255.255.254.0. So that means this one is 255, this one is 255, this is 255. So this one is 0. So we are removing 2 power 0. So 255 minus 2 power 0. So that is 254. Yeah. All right. So whoever got binary, someone got binary wrong. Okay, that is wrong. Okay, yeah. So this one is the right answer, guys, and this one is the right answer. Okay. If you are not able to follow, guys, please try to understand the subnetting and how are you representing that. Okay. I'm gonna stop there, guys. Any questions? Any questions, guys?
No, sir.